So in this video, we're going to look at making sign charts. So sign charts are showing the relationship between the original function and the first derivative, or the original function and the second derivative. Sign charts are really helpful in determining max, mins, where a function is increasing or decreasing in concavity. So we're going to look at making a sign chart for these. In terms of sign charts, there's different ways to write them, and so it's kind of whatever you're comfortable with. I feel like every professor does them differently. So usually when I make them, okay, I make like a number line, and the key thing is we start with is those turning points. So we're gonna put kind of the major where things change. But so if I do a number line, we're gonna do our turning points first. So we know there's a turning point at x equals -2 and x equals 0. So I'm gonna put those on my number line. And you don't even have to put the x values, we should know they are. And then I'm gonna put our f, which is talking about what is our original function, and then f prime for what is my first derivative doing. So for this, these x values, what we're gonna do is we're gonna say, okay, what's happening in each of these intervals? So this is saying before -2, what is happening? And before -2, my function is decreasing. So whenever we say it's decreasing, we put a down arrow. And then at -2, we know that that is a min. So I'm going to put min. And then when we go from -2 to 0, we know my function is increasing. So I'm going to put an up arrow. We know 0 is a max. And then after 0, from then on, it's decreasing from then on. Okay, so this is telling me what f is doing in each of the intervals. And then if I talk about f prime, well, I know anytime it's decreasing, f prime is the slope, and the slope is negative. And we know at the min, the slope is 0, so we put 0. When my function is increasing, the slope is positive. At a max, my slope is 0, and when it's negative, my slope is decreasing. So this is a sign chart, and usually they don't put x equals, just put -2. So that's one way to write it. Some, like if you watch the other video with the other professor, she puts like f prime of x down here, and then writes x here and puts the x values like -2, 0, and then has the intervals like this. So you can write it that way. She just puts the x values, she does not put the arrows. And then puts what happened with the derivative, and then like below she writes it. Is one way. The other way is some professors do intervals, which is fine as well. So you can write all your intervals. So you have -infinity to -2. And then you have -2 to 0. You again have to find the turning points. So I'm writing these intervals. And then 0 to infinity. And then they put f prime. So again, f is from this first interval decreasing, then it's increasing from -2 to 0, then it's decreasing from 0 to infinity. So the slope is negative when it's decreasing and positive when it's increasing. So that's another way to do a sign chart. So the main point of the sign chart is to show the relationship between what is happening from f and f prime in one like easy picture to see. Okay, so this is the graph of f prime of x. And for this graph, we want to make a sign chart. So again, okay, I'm going to start with f prime and f. Now, we approach this graph really differently than the last one. So we're interested, like we were on here, at where max and mins are, and that's where the derivative is equal to 0. So when I have the derivative, the critical values are where the derivative equals 0, or where the derivative crosses that x-axis. So that's what's going to go on my number line. So I would have 1, and then 6, and then 8. And these are the 3 places where the derivative is 0. So then from there, I'm looking at the derivative because that's what I have, and then I'm going to figure out f from there. So this derivative, I'm not looking if it's increasing or decreasing. I'm looking at the sign of it because the sign determines what's happening with f. So this part of the derivative is below the x-axis, which means its values are negative. And so this derivative from negative infinity to 1 is negative. From 1 to 6, the entire time this function is above the x-axis. So this derivative is positive. I'm looking at the actual values of it. And then between 6 and 8, the values of the derivative are negative because it's below the x-axis. And 8 after, the values are positive because it's above. So what that's saying is when my derivative is negative, f would be decreasing, and then it would be increasing. Here it's the slope is negative, so it's decreasing. Here's the slope is positive. And so this is a min, because it's going from increasing to decreasing. This is a max, and this is a min. And again, you can write it as intervals if you want. So that is the side chart. And the key thing with this is remembering this is the first derivative. So this is not a graph of the original function. It's the graph of the slopes. And so the y values of this graph is telling us what the slope is of the original graph. And sometimes that's really hard to wrap your mind around. But if you're given the derivative graph, start with the zeros. And then look at where is your function positive or negative based on if it's above or below the x-axis. Fill in this whole row, and then once you have that, knowing the relationships, you can just fill in f. So those are your 2 types of sign charts for the first derivative.